In the last few videos, I've talked all about different types of functions, how you can define them, arrow versus normal functions. And in this video, we're going to talk about some debugging techniques that you can use to find errors specifically related to calling functions. And this is going to be through the use of the call stack and the stack trace. So I just have a really simple here an example. We have a lot of functions we've used before. We have a print function that takes a variable and is going to log that out to the screen. We have a sum that takes a, b and prints out or returns a plus b. Say hi, which just adds hi to the beginning of any name. And then we have this big do stuff function up here, which takes a and b and a name, and it's going to sum a and b together and then print that out to the screen. It's going to do the say hi function where it adds hi to the beginning of our name, and then it's going to print that to the screen. So if we call do stuff and we pass it 1, 2, and then my name of Kyle, and click save, you see it prints out 3, and then it prints out hi Kyle. So it's working as we would expect. But a lot of times when you're writing code, you're going to have errors. I mean, you never write code and it works the first time. So let's say inside the sum function, for example, we have some error. We're just going to say here, some gibberish code. This is our error. So when we save, now what's happening, if we go back to our console here, is we're getting an error. It says uncaught reference error, ASDF is undefined. And it tells us down here our stack trace. And this stack trace essentially tells you what order all the functions were called in to get to exactly where you are. So it's saying what happened. At the very top of the stack trace, we see at sum. So the very first thing in our stack trace is the most recent function that was called. And then it's saying, so at sum on line 11, that is where the error occurred. And then if we jump backwards out a function to the previous function, it says in do stuff on line 2, that is where we called the sum function. And then it says in our script.js file on line 19 is where we called do stuff. So it works backwards from the inside to the outside. So the very first definition on our stack trace is the most inside function, the one where the error occurred. And the very last thing is the outermost function of where we started this whole entire rabbit hole to getting where we are. And the nice thing is we can just click on any of these inside of our console. So say script.js on line 11, we click there and it brings us exactly to line 11. It says, hey, this is where your error is. This thing is not real code. It's bad code. And obviously, well, this is bad code. So we'd have to delete this over here in our VS Code, and then everything would work just fine if we did that. And let's say we got to that line and we went, I don't see any error here. Everything here looks fine. We just go to the next step. So it says at do stuff on line 2, we click this and it does our function here. It's saying, hey, we called sum here. So now you're saying, okay, maybe the code actually is broken here. Maybe we're passing a value we don't expect into this sum function. So you can check here. And let's say you're like, oh, you know what? This do stuff, that works fine. It looks good to me. You jump back a step further and go to script.js on line 19. Look here where we call do stuff. And maybe here is where you have your error. So you can check here and be like, oh, is my error here? And you can continually do this on and on and on until you get to the very end of your stack trace. And you'll notice this little arrow here. Sometimes your stack trace may be really, really, really long. So if you click here, you can go through and it'll list out every single thing. Even if you have hundreds of functions called in a row, it'll show you them all in order from very top to all the way at the bottom. Because sometimes this won't actually show everything if you have too many until you click this arrow here. So now what exactly is the call stack? In order to see the call stack, what we want to do is click on this sources tab over here and make sure this button down here, this little stop sign, shows up as blue. What this is going to do is it's going to stop whenever there is an error. So let's come over here and let's just resave this. And you're going to notice immediately we're highlighted in blue over here saying, hey, we're having an error on this line. It says it's paused on exception, and here's our error right here. So right now our code is paused right here. You notice there's no error in the console because everything is paused. And you can see that we have this thing called the call stack. And the call stack is just like our stack trace, but it shows us the functions where we are, and you don't need an error to get to a call stack. So here we have our sum. We can click do stuff. And as you can see, it's brought us up to do stuff. And you can see we have a bunch of different variable information on the right-hand side here. You can see we have all of our local variables, A, B, our name, everything is showing up over here. We can go back to sum and you can see we have A and B, which are 1 and 2. So it really allows you to see exactly what's going on in your function if you have this kind of call stack enabled, and you can see a scope of all your different variables. We can go all the way out to here to our anonymous scope, which is just, our actual function itself. So it really allows you to just dive into the different functions and the different sections of your code to figure out exactly where things are occurring. And this call stack is super useful when you want to kind of dive around, see what all the values of the variables are. But right now, the only way we can get to this is with an error. What happens if we don't have an error? Well, what we can do instead, if we just widen this back out, get rid of our error, and we click save, and make sure we click this resume script button here. That'll actually allow us to continue forward. So we're going to get the error over here. Now if we save, we get 3 and hi Kyle being printed, and we don't get to check out our call stack because there is no error. What you can do is inside of a file, you can just click on one of these line numbers here, and you're going to notice a nice little blue thing shows up. This is essentially a breakpoint, and you can see the breakpoint down here. So now when we run our code and it gets to this line, it's going to pause our code and it's going to allow us to see exactly what's happening inside the sum. So if we resave, you're going to notice we're paused right here. It says paused on breakpoint. We're paused on this breakpoint where it has A plus B, and we have our call stack. So we can say, oh, what was do stuff? Oh, what was happening here? What was happening at sum? We can see all the different values, and we can really just dive into exactly how our code is working, which is really useful for if you have potential errors and you want to really dive deep into exactly where they are. This call stack can be incredibly useful. Really, the big thing to worry about when you get into the call stack here is now you have a bunch of different, operations you can use. So for example, you can click this resume button and it's just going to resume your code until it hits the next breakpoint or until it's done running everything. Let's just rerun our file by saving again, getting back to that breakpoint. Next thing we do is called the step into function call. So if we just click on this, it's going to step into our function. Essentially, it's going to jump to wherever we are. So if we click step into here, where we're on this line where it's calling print, we're going to step into the print function. So if I click this, you can see it's now running our code line by line, and we just jumped into this print function. And now here we can step in further and further and further as we need to. So this is just going line by line by line. And then what we can do is say, you know what, we don't want to step into this print function. So we're going to click step over, and it's going to skip the print function. It's going to run it still, but it's just going to move us to the next line of our code. And it's not actually going to jump us into the print function. So it's going to run everything in print without us actually having to run each line manually one by one. And then we can just continue forward. And now we've gotten to the end of our program here. We click it one more time. And now we're moving into code that's not even ours. So we'll just click resume, and that's going to finish everything out for us. And as you can see, it printed out everything just fine back to our source. So we can step through our code line by line if we want that. Let's just save again to look at that again. We can click this step out. And what that does is it takes our current function in our call stack and it exits us out of it. It still runs the whole function and it exits it out of it and puts us inside of do stuff. So we click that. And now we're back inside of do stuff. If we were to click this again, it's going to jump us out of do stuff. It's going to run everything and put us back at the next point in our call stack. So we click it. And as you can see, we're now at that next step in our call stack, the anonymous, and we're all the way down here. We click step out again. And now we're in code we don't actually own. So we'll just click resume, and there we go. Everything logged out just fine. So this debugger over here is really useful. You just, click on different lines that you want. You click on it again to remove the breakpoint, click somewhere else to add a new breakpoint, and so on. And you can really dive into how your code's working. The important thing though is when you have an error and you click save and run and you come over to your console, this stack trace right here is incredibly important to really kind of just figure out where the error happened really quickly. And if you still can't find out the error just by looking at the stack trace and looking at your code, then diving into the debugging tools and really looking at the call stack and all the different variables, that can really help you find exactly what's going on. Now these last few videos have been some pretty complex topics, so luckily in the next video we're going to talk about something called hoisting, which is actually a very simple topic to talk about, so I can't wait to see you in that video.